Here we've got one of the SAT's classic moves. We've got a geometry question with no picture, so the first thing we should do is draw the picture. So triangle PQR, and we can just kind of quickly draw that. And the only thing is that Q has to be the right angle, so let's put that there. The other two don't really matter. So they tell us sine of R equals 4/5. What is the value of tan P? The only thing we really need to know for trigonometry on the SAT is SOHCAHTOA. This is the shorthand that reminds us of all the trigonometry functions. There's another trigonometry rule that sometimes comes up on questions on the SAT, but it's like 10%. 90% of trig on the SAT is just this little mnemonic device. So I'll show you how it works if you're not familiar with it. Basically, what we do is we use the first letter to tell us what trigonometry function we're looking at. So sine means we're looking at the SO portion. Okay. So what that means is that the sine of an angle is equal to the opposite side over the hypotenuse, right? O is opposite, H is hypotenuse. So that's what the SOH stands for. Reminds me of what I'm looking at. So in this case, the sine of R, which is this angle right here, is 4/5. So if I match that up with the opposite over hypotenuse, that tells me that the hypotenuse of this triangle is 5, and the opposite side, the side opposite angle R, so over here, is 4. Right? You go across the triangle. QR here is the adjacent. Adjacent, I'll write out the whole word. And that's what the A in ka and toa stand for. Okay? So we're going to see that next because now we're told the value of tan P. So, okay, tan, according to SOHCAHTOA, is the opposite over the adjacent. And so in this case, we're looking at tan of P, so that's this side right here. So I have the adjacent, that's what 4 is. So notice, the weird thing about trigonometry is depending on where we are in the triangle, the opposite and the adjacent change. So now this is not the adjacent, that's the adjacent of R. This is the opposite of P, because now across from P is QR. So you always got to know your bearings when you're dealing with a right triangle. What angle are you at? Because the opposite and the adjacent switch depending on where you are. The hypotenuse is always the same. That's always the longest side, the side that's opposite the 90-degree angle. So that's easier. But looking here, we don't know the opposite side. We're missing it. So the long way to find it is just to use Pythagorean Theorem. A squared plus B squared is C squared, where C is the hypotenuse and A and B are the other two sides. So I'll keep A as mystery and we'll put 4 in for B. And so A squared is equal to 16, or plus 16 is equal to 25. And we can subtract the 16. A squared is equal to 9. And so A is equal to 3. So that's this side right here, and that's going to go there, and that's going to be our answer. The tangent of P is 3/4. You can bubble it as 3/4. You can bubble it as 0.75. It doesn't really matter. So Pythagorean Theorem is great when we have two sides of a right triangle and we need to find the third. But in general, on the SAT, when we're dealing with trigonometry questions, you shouldn't be surprised if you find triangles that are in the 3, 4, 5 proportion. It's just a nice, what's called a Pythagorean Triple. It's just a nice set of numbers that tend to make right triangles. And so a lot of your trigonometry answers are going to look like this: 3/4, 4/3, 5/4, 4/5. It's the same numbers again and again. But just remember too, it's a proportion. So one of the other things that you might see is something like 6, 8, 10. Right? It's as if we had multiplied all those numbers by 2. That would also be a Pythagorean triple. That would also get us a nice, clean right triangle. So we could do multiplying by 3 as well. 9, 12, 15. We can multiply them by 100 if we wanted. 300, 400, 500. These are all perfect Pythagorean triangles. And so that lets you, if you know that, if you see that, that lets you skip the Pythagorean theorem step. But if you forget it, you still have Pythagorean theorem to get you that answer. So yeah, memorize formulas. We just need one. SOHCAHTOA here gets you sine, cosine, and tangent, and that's going to get you 90% of your trigonometry questions in the SAT. It's worth memorizing.